If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture intermediate level where you are building concepts on different types of functions. So today we will see modulus function, signum function, greatest integer function, and then fractional part function. Okay, then let's understand this. Now next, what is modulus of a function? Suppose if I say y equal to mod x, so this has different meanings. I will try to explain it one by one. So what is mod x? Mod x is a modulus function. It can be also defined as minus x plus x, because mod is nothing but it will take the positive value of this one. Actually this is not the meaning of this one. In complex number you have already seen, because I have only number line, I don't have any both the x's. Suppose I have only x axis, because I don't have two code. Here x is input, so input is only one dimensional, so you can go either this way or this way. Suppose this is 0 0 0, so this is a point, suppose 5, this is a point. So what is the distance from here to here? 5 unit. What is the distance from here? 5 unit. So mod x is nothing but x minus that point. So it is the distance between x and 0, that is they are talking about. In z, in complex number also, z minus 4 was this one. What was this one? Suppose if I say z minus 5 is 2, z is two dimensional, because input is here x and y both, because x can take input z, that can take two values, because that has two part, real part and imaginary part. So the distance from that point 5, 0 is 2 out, so it was a circle, because z can move anywhere where the distance is 2 units. So it is nothing but giving the distance. So mod actually gives the distance between this and this. In one dimensional it becomes either positive or negative, but in two dimensional it's just doesn't means positive or negative, because it can go in either. Here you can go either this or this, two way. So in both way you take the positive values, but here you can go this way, you can go this way, you can go this anyway. If I say mod z equal to 5 in complex, it means a circle of unit 5 radius. You can go this side also plus 5, you can go this side also minus 5, you can go this side also, which is not a plus minus. So that's why there is a difference here. So you understand the concept of modulus. Modulus is nothing but distance between that point and origin. If we say, suppose if I say mod x plus 2 equal to 3, what is the meaning of this one? X minus 2 mod is 3. So from the point minus 2, the distance should be 3 units. So how much you can go? 3 unit you go here. So answer, you can either land at 1, or if you go 3 unit, 3, 4, 5, you can land at 5. So your answer is x equal to 1 or 5, minus 5. You open it, you use this, all this formula what you have learned till now, plus minus give, you will get that, you will get this two answer. Basically it is nothing but it is the distance from minus 2 to that value. So that is modulus. Okay, we are not defined what is the definition of modulus, just I have shown you. So you can expand it in this way also, which is known as piecewise defined function, because we are defining function by breaking the function. We are defining piece by piece, one piece, one piece, one piece. If x is negative, then what is the purpose of mod? To make it positive. So to make it positive, we will put one more minus. Suppose it is minus 2. So if I give one more minus, then automatically the job of mod is done, plus 2. And f is greater than 0. If it is positive, then there is no need of mod. You can simply write x. So that's why this function is generally splitted. So mod generally dealt with this type of, by splitting it. Two functions, where it is positive, then you just remove mod, where it is negative, just put a minus in. So if you draw this one, if x is greater than 0, for positive it is simply y equal to x. So this line, this entire graph, both this graph together makes this one, but only if you see this line is y equal to x, and if this line is y equal to minus x. For less than 0 it is this line, for greater than 0 it is this line. So which is also known as piecewise defined function. You remember this graph, this is important. So the graph is symmetric about y-axis, you can see. So it is a mod x is an even function. What is the domain of mod x? First you see mod x, then you will see 1 by mod x. You can put any value of x. You can see for any value of x you will get output. But what is your y? Output is either positive value or 0. Now if it is 1 by x, then you cannot put 0. From real number you take out 0. And output you can, because when 0 was coming, when you give input 0, then 0 was coming. But here you cannot give 0 input. So your 0 output will not also come. So his output is always positive numbers. That's why it is R plus. R plus means positive real numbers. Next is signum function. Not signum, signum function. So signum function is this one, y equal to fx, x by mod x, if x is not equal to 0, because 0, 0 it is not defined. And if at 0 it is 0. So it is defined in this way. Particular definition you have to remember. At 0 it is 0. Or you can write it in this way also. If it is negative, then what is its purpose? X will be x, instead of mod x what we will write? Minus x. For negative what we write? Minus x. So x by minus x will be minus, and at 0 it is given 0. So if it is greater than 0, then there is no need of mod. You can directly simply write x. So x by x is 1. So you can or define it in this way also. This means this. So either this way or this way, both means same. So you have to remember both ways. So if you draw it now, for greater than x, it is 1. For greater than 0, positive. So if you draw this graph, for greater than 0 it is 1, for less than 0 it is minus 1, and at 0 it is 0. So this is also a point on this graph, and this is not a point. This circle means this point doesn't include in that circle, this point. That what is the coordinate of this point? 0, 1. So 0, 1 doesn't satisfy in this function. So this is the graph. You have to remember this graph. This circle, again I am saying, this doesn't include these points. So these points and these points are not included, but this point is included. So this is included, so you have to remember. So this one I am darking, and this is hollow circle means these points are not included. So this is also written at SGN, short form Signum of x. This also means this function. So you have to remember all these graphs. And you see this graph is symmetrical about origin. This point, you take image of this point on origin, you will get this point. You take image of this point, you will get this point. So image of this line on this point is this one. So this is symmetrical about origin, that's why it is odd function. Signum is a odd function. While it is domain, you can put any value of x, you are getting output. Even for 0 also you have 0 output, all values you have output. But what is the output? Output is either 1 or 0 or minus 1. There are only 3 outputs, so range is these 3 values only. Next is known as greatest integer function, which is also generally we say it is a box x, just to remember, but it is a greatest integer function. Y equal to fx, which is a box function, is known as greatest integer function, where this box x denotes the greatest integer less than or equal to x. So if you have a value, what should be its greatest integer in the left side? You have to remember the left side, because if I say 2.9, so what is in 2.9? What is integer? Greatest integer 2. So that is in the left side. So I have given some examples so that it becomes easy. If I put 2, box 2 is 2, because the greatest integer possible here is 2 itself. 2.9 greatest integer is 2 here. 2.9 is also greatest integer. What is possible here? 2. 0 is 0. But if I say minus 0.5, then you don't say 0, because I am saying left hand side. So if minus 0.5 is here, so what is left hand side? That is minus 1. So your output will be at minus 1. So minus 0.5, output is at minus 1. Minus 0.9, again here. So left hand side integer is highest integer. Left hand side there are lots of integer. Out of this, highest one is minus 1. Just immediate left you see. Here also 2.9, just immediate left 2, so your output is 2. 2.1, just immediate left, that is 2, so your output goes to 2. So here minus 2.1, just immediate to that one, minus 3, so output comes at minus 3. Again minus 2.9 here, so just left is minus 3, so it will come here. So if you draw this graph, it looks like this, which is also known as staircase functions, like your staircase in your home. Stairs. So what is these are all stairs. You can see you can climb from 1 to 1, 1 to 1. So this is looking like staircase function. Again, these circles means that points are not included, because if it is 1, then what is the output? Output is not 0, output is 1, so it will directly go here. If it is 2, then output is 2, so it will directly go to here. This is your output. This is your output, this is the input. So that's why it is known as staircase function. The input, you can see you can put any number input. So input is R, domain is R, but output is only integers. Either 1, 2, 3 or minus 1, minus 2, only integers. Now it is 1 by box x. If it is, then you cannot put, what you cannot put, the denominator should not be 0. So when it will be 0? When your input is between 0 to 1. You can see if your input is 0 to 1, your output is 0. That cannot is possible, because 1 by 0 will be undefined. So you cannot put any number starting from 0 to 1, not including 1, because if you give 1, then output is 1. That is possible, but you cannot include 1 just before this one. So this line should be taken out from the x-axis if it is 1 by box x, because this will give me 0 output in the denominator, which is not possible. Now what is again output? 1 by n. Again n is all integers, but again it is output is not also 0 possible, because here only output was 0, but because you are removing this one, so your output cannot be also 0. Now what is x plus box of minus x? It is 0 if x is integer. So if I say plus 2 box minus 2, what will be this one? It is 2 plus minus 2, because just minus, if I say minus 2, that means this is the highest integer I have. So either this one or just left, so it is 0. Yeah, similarly you can go for 3, 4, whatever. And if it is not an integer, suppose 2.1 and then minus 2.1. So 2.1 is 2 left, and minus 2.1 left is minus 3. Because minus, it will move 1 point left. You can easily visualize now, so it will be minus 1. So that's why it is important, you have to remember what is the meaning of this. Next, what is fractional part function. Just like your box x, it is also denoted by second bracket, this type of bracket of x, which is known as fractional part of function. What is the meaning of this one? This can be also written as x minus box x, because it will give you only the fractional part of that function. Some examples I am showing you so that it becomes easy for you. So 2.1 fractional part means, you remember this one, this is also you have to remember, this is nothing but this, x minus box x. So 2.1 minus box of 2.1. So box of 2.1 is 2, so 2.1 minus, so only the fractional part of this one it is coming. Now interestingly, if it is minus 2.6, then it is not minus 0.6, because your output should be only from 0 to 1. You can see it is x minus box of x, so minus 2.x minus box. What is box of this one? It is minus 3. So if you do this on 0.4, so how come 0.4 is there? 0.4 is inside there, so because if you take the highest integer in the left hand side, it is minus 3, and from that if you add 0.4, then it is coming minus 3 plus 0.4. So it is only taking this integer part. So this output is always between 0 to 1. Only the fraction it will take, not negative fractions. 0 to 1 positive fractions. So that is also, so you can see this one, if you go from here, you can see if it is 2.1, your output is 0.1. So 2.1 output is 0.1 only. 2.9 output is 2.1 output is 0.1, 2.9, 3.1 output is again 0.1, 3. So output can go up to not 1 because it is fraction, so just below 1, 0.99991, because if you give fraction of 3, then it will not be 3, it is 3 minus 3, it will be 0, it will land it here. So if you give 3 only, so it will be 0. If you give 3.1, 3.2, 0.2, 3.3, 3.9, again if you give 4, it will be 0, 4.1, 4, 1.1. So it will every time it will give between 0 to just below 1. So it is also looking like a sawtooth saw. We have seen the saw to cut your wooden block. So that likes a sawtooth wave function. So again this circle means these points are not included. As you can see, if you put 2, the output is not 1, it is 2, output is 0. So at this position your output is not this, output is this. So you can see this line, this is actually y equal to x line, this line is moved towards left right. How to move left right, I think I have explained, or I will explain in application of derivatives. So if you move it, it is a y equal to x minus 1, this line if you take, this line if you take a y equal to x minus 2, all these lines are straight lines only, inclined at 45 degree. So if you take the domain, again you can put any value of x, for any value of x you have output, but your output is only on between 0 to 1, not including 1, this is excluding 1. Now if you do 1 by this, then you cannot put r and you cannot put point when it is 0. Where it is 0, output is 0 is 0, 1, 2. If it is an integer, then your output is 0, because in integer the fraction part is 0. What is this one? This is nothing but 0. Fraction of 2 is 0, fraction of 1 is 0, these points. So you remove all these points, so all integers are removed, because at that point the output is 0. You don't want output to be, denominator should be 0. So in that case, what will be your output? If you take 1 by inverse of this one, 0 to 1, if you inverse it, it goes beyond 1. So it is from 1 to infinity. 1 it cannot be, because it cannot reach, this cannot reach 1. So its inverse also cannot reach 1. If you like the video, then press the like button and please give your valuable comments in the comment section.